Island Link has weekly excursions of 156 kilometers from Port R to Port S on a bearing of 85 degrees. Then 90 kilometers to Port T on a bearing of 205 degrees before returning to Port R. So here is our diagram, and they want us to calculate the angle RST. So let's first label RST, and our goal is to figure out what is the size of RST. So this is R, S, and then T, okay? So they actually want the angle in the middle right there, S. So our goal is to figure out, okay, what is the size of angle S? That's the goal, right? What is the size of angle S? Okay, and so that's what we have to figure out. Now, in order to do this, what we're gonna do is we're gonna figure out what is the size of angle M first. Okay, so angle M is this particular angle, all right? We call it angle M. And so what is the size of angle M? Well, notice that this is north and this is our north line. And these two lines are parallel to each other, right? So these are parallel lines, all right? And so we have this line that touches these two parallel lines. And if you notice carefully, we are able to form a C shape, all right? We're able to form a C shape. So we have this, this line, and then we have goes this way, and we have this one goes this way as well. So notice that we have a C shape, and so we have this angle and this angle M. And so if we have a C shape that is formed with these parallel lines, just like this, with this transversal that is here, then this angle and this angle, these are co-interior angles because we are able to form this C shape with our parallel lines. And so this angle here and this angle M, these are co-interior angles, right? Co-interior angles. Now, what do we know about co-interior angles? Well, co-interior angles are supplementary angles, which means that they add up to 180 degrees. So if you want to figure out what is M, M is going to be 180 degrees minus 85, which gives us 95. And that's because 95 plus 85 adds up to 180 degrees. And that's what happens with co-interior angles. They add up to 180 degrees. So M right here is 95. Okay, so M right here. So M, this angle M right here is 95 degrees. All right. So we know what M is. So far we know what M is. M is 95, the same thing. This is 95 degrees. We also know that, let me erase all link. So erase all link. So this right here is 95 degrees. So this is 95 degrees. And we also know that from here all the way to here is 205 degrees. And so our goal is to figure what is the size of this angle right here, all right? Now, what we do know is that a full revolution is 360 degrees, and angles around a point add up to 360 degrees. And so if we want to figure out what is this angle right here, we're going to add 95 and 205 and take that sum and subtract it from 360 degrees. So we have 360 minus 95 plus 205, and 95 plus 205 is 300. And so we have 360 minus 300, and 360 minus 300 is 60 degrees. So this angle right here is 60 degrees. So RST is equal to 60 degrees. And 60 degrees plus 95 plus 205 add up to 360 degrees. And so that's our answer for this question. Next, our goal is to determine the distance from port R to port T, given your answer to the nearest whole number. And so what is the distance that we're trying to find? The distance, let me use yellow. So the distance from port R, right, to port T. So we need to figure out what is the size of this particular, or what is the length of this particular distance, RT, right? And so what we're gonna do is we're gonna use the cosine rule for finding missing lengths. And the rule says that a squared is equal to b squared plus c squared minus 2b c cosine of capital A. The missing side RT, right? The missing distance we call small a. And the angle that is opposite the missing side, the angle that is opposite the missing side, we call it capital A. So small a is the missing side, and the angle that is opposite the missing side, we call it capital A. So this is capital A, and capital A is 60 degrees. And the other sides of the triangle, are B and C. So this is actually supposed to be, let me move this. This is not C. I mean, this is not B. This is actually C, okay? So C is 90 kilometers. Again, C is 90 kilometers, and B is 156 kilometers. So A is the missing side, capital A is 60 degrees, small b is 156 kilometers, and small c is 90 kilometers. And so that substitute, we have that b is equal to 156, c is equal to 90, b is equal to 156, c is equal to 90, and capital A is equal to 60 degrees. And so we have 156 squared plus 90 squared, and that gives us 32,436. And we have 2 times 156 times 90. Again, 2 times 156 times 90 is 28,080 multiplied by cosine of 60. Next, we subtract. So we have 32,436 minus 28,080 times cosine of 60 degrees. And that gives us 18,396. Again, 18,396. And so we have a squared is equal to 18,396. We take the square root of both sides of this equation, and then we cancel the root with the power. And so we are left with a is equal to the square root of 18,396. And so that means that a is equal to 135.631,854.7. That's what a is equal to. But they want us to give our answer correct to the nearest whole number. And so we look at this number here, and this is 6. And so since this number 6 is greater than 5, so we add 1 to 5, and that'll be 6. So a is equal to 136, and that's correct to the nearest whole number. So that means that the distance from port R to port T correct to the nearest whole number is 136 kilometers. Next, we need to figure out what is angle TRS, angle TRS. So let's label this angle TRS, angle TRS. So this is TR, angle TRS, angle TRS. So they really want us to figure out what is the size of angle R. And so let's highlight that. So this angle right here is what they want us to figure out the size of. This angle right here. Okay? This angle right here. And so how are we gonna do that, right? Well, what we're gonna do is we're gonna use cosine rule, and the cosine rule for finding a missing angle is equal to cosine of capital A is equal to b squared plus c squared minus a squared all over 2bc. Here we label capital A as this angle because capital A is equal to the missing angle. So we label the missing angle as capital A. Okay, that's what the missing angle is. The missing angle is capital A. And the side that is opposite the missing angle, we call that small a. All right, the side that is opposite the missing angle, we call that small a. And the other sides of the triangle are B and C. So B in this case is 156 kilometers and C is 136 kilometers. And so we substitute those values. B is 156, C is 136, A is equal to 90, B is 156, C is 136. And so we evaluate the numerator and we get that 156 squared plus 136 squared minus 90 squared is equal to 34,732. And we have 2 times 156 times 136 gives us 42,432. And so we have cosine of A is equal to this fraction. And so what we're going to do is we take the cosine inverse of both sides of this equation. This and this cancels out. So we left that A is equal to cosine inverse of this fraction. And so A is equal to cosine inverse of this fraction, which is equal to 35.06177,189. Now, writing this correct to two decimal places, we know that this is 1. So since it's less than 5, we cannot round up. So we just leave it as 35.06 and we eliminate these decimals. And that's our answer correct to two decimal places. So that means that angle TRS correct to two decimal places is equal to 35.06 degrees. Next, we move on to calculate the bearing, right? So you need to calculate the bearing of port R from port T. Okay, that's what you need to find out. What is the bearing? The bearing of port R, the bearing of port R from port T. Okay, that's what we need to figure out. What is the bearing? Okay, what is the bearing of port R from port T? Okay, and so let me use a different sign here. So let's use this. So we have to figure out what is the bearing of port R from port T. Okay. Now, if we notice carefully that, okay, we cannot use this. Let's not use this one. Let's use this. Okay. So if we notice that we want the bearing of port R from port T. Okay. Now they say from port T. So we got to go to port T, right? We're going to draw our north. So we have our north here. And then we're going to go and we're going to draw this angle here like so. Okay, so this is what they want us to figure out. They want us to figure out what is this angle right here. All right. So let me erase that and show you it again. So we want to figure out what is, so we go to T, we say the bearing of port R from port T. So we start at port T, we draw a north. They already have the north drawn for us, so that's good. We draw a north, and then we go from here, and we go all the way here. That's the angle that we're trying to figure out, okay? So what is the size of this angle? Okay, so let's figure that out, right? The size of this angle. Okay, what is the size of this angle? Let's figure that out. So let's figure that out. So we have, let me erase all this so it can be clearer for us. So let me erase. So erase this. Okay, so that's good. And so we have this. This is our bearing, the one in green. That's what you're trying to find, right? The one in green, right? Start at the north, go all the way, and that's the bearing that we're trying to figure out. Okay. And so if we're trying to do that, what we're gonna do? Well, we know that this is 36 point. We know that this angle right here, which we figured out, correct to two decimal places, it's 35.06. All right. We know that is this angle. What else do we know? Well, we also know that angle Q. Now we want to figure out what is the one in green, but we label angle Q because Q is going to help us define the angle that is labeled in green, right? So we have Q, and we're saying that Q, right? Q is equal to 180 minus 85 plus 35.06. Now the reason why we say that is because if you notice carefully, this right here is a parallel line. I mean, this right here is a north, and this right here is a north, right? These two lines are actually parallel to each other. And so what does that mean? Well, that means that this angle right here, the same one, along with this angle right here, these two angles are co-interior angles. And we know that they are co-interior angles because you could form a C, right? So you could form a C. So if you notice carefully that this go up, right? Go up and then go up. I don't notice that you see the C, all right? So yeah, so like a C shape. And so that's a big hint that we're dealing with the co-interior angles. So that means that this angle right here, along with this angle Q, these two angles right here, they are what we call co-interior angles. Now, what do we know about co-interior angles? Co-interior angles are supplementary, which means that they add up to 180 degrees. And so that means that Q, right? This Q, along with 85 plus 35.06 must add up to 180 degrees. And so what we're gonna do is we're gonna add these two. And when we add 85 and 35.06, we get 120.06. And so we have that this is these two angles add up to 120.06. But we want to figure out what is Q. So Q is going to be equal to 180 minus 120.06. And so when we subtract, we get that Q is equal to 59.94. And so if this is 59.94, if Q is 59.94, and we add that to 85 and 35.06, all of them add up to 180 degrees. And that makes sense because co-interior angles add up to 180 degrees. So Q, right, this Q right now is equal to 59, right, 59.94 degrees. That's what Q is equal to. Now, what we want to figure out, what is this, right? What is this? What is this angle right there? Now we know that the whole thing must add up to what? To 360 degrees, because one revolution is 360 degrees. Angles around a point is 360 degrees. So if we want to figure out what is this angle in blue, what we need to do is we need to take 360 and subtract it with 59.94. Again, we take 360 and subtract it with 59.94. And when we subtract it, we get 300.06 degrees. And so that means that this angle right here, right, this bearing is equal to 300.06 degrees. And so that's the answer for this question. The bearing of port R from port T is equal to 300.06 degrees. Quick recap, what did we do? Well, in order to find this bearing, the first thing we did was we have to figure out what is Q. And we figure out what is Q by identifying that this angle and Q are co-interior angles. So that means that they must add up to 180 degrees. We add these two angles, and we take their sum and subtract it from 180 degrees, and that left us with 59.94 degrees. So we got that Q is equal to 59.94 degrees. But we know that altogether, right, this is 360 degrees. So if we just remove or take away 59.94 from 360, we would be left with just the bearing. And so that's how we got the bearing. We take 360 minus 59.94, and that gives us 300.06 degrees, correct to two decimal places. And so that's going to be our answer to this question.